Alright, time for another draftphysics.com, debatephysics.com video presentation. Just gonna do some more of the same, arguing for a more reasonable, sensible, simpler diagram of reality than the one Bohr and Einstein gave us, gave everyone, gave the humanity. And it's just wrong and stupid and ignorant and silly and crappy, non-mechanical, not real. It just sucks. So Einstein with his stupid bent geodesic, his fake mechanism that just happens to make gravity through some who knows how mechanism, complete non-explanation that everybody calls an explanation when there's no explanation. And then it adds this silly notion that somehow you can change what time it is, by moving somewhere. You can go somewhere and somehow you'll go to the past or something, or you'll take your present and move it into somebody else's future or something. I don't know. Doesn't make any sense. You can't mess with time. It's the same time everywhere. You can't escape time. Anyway. And then Bohr's silly, stupid model of the atom with the spinning electron-y things and all that, the nonsense that goes with it, all this superpositions and entanglements, and electrons create, they have magnetic moments, somehow they're dipoles, but they're monopoles, but they're dipoles, or some kind of crap. Way too complicated, and then they add a whole bunch. Modern physics has decided there's about 400 other particles that are doing something, plus all of the antiparticles for all of those particles, so that's 800 particles. I mean, it's just so bad and so ridiculous, and it is a push-averse, so it's even like these little simple arguments about, physics has never been challenged. No physicist has ever challenged to just say, well, how would I create an elemental pull? I know I can make an elemental push by just having a collision. So a collision guarantees a push. But how do I make an elemental pull? And, it'd be nice to just see a physicist explain what the hell an elemental pull would be. What that would be, how you could have one of those. And then the same kind of argument comes up with this waving stuff. How could something elementally be a wave? It's a rather complicated behavior, waving. It really can't be elemental. It can't be fundamental. And so these are all really bad explanations for the reality. And you don't have to do much thinking. You just start saying to yourself, well, how do you diagram this machine? And if you just start with the basics, the things you can really know, and that is, there's charges. So there's such a thing as an electron, and there's such a thing as a proton. Okay, and the weird one is this neutron thing, right? So let's just leave that out. But look, the simple argument is modern physics already knows that the neutron decays. That means it falls apart, and when it falls apart into a proton and an electron. So should I even have to make the argument that let's not talk about neutrons, because they're a figment of your imagination, in the sense they only really exist as a consequence of electrons and protons actually being very close to each other. So if you can get an electron and proton really close, they'll tend to stay there, okay? Unless you knock them out of a nucleus, and then they'll decay into basically hydrogen. Could be argued. But regardless. Alright, so just having that, just saying, okay, that's what we start with as matter. And we just say there's no other matter. There's just electrons and protons. They make up charge. Charges do all the work inside of atoms pretty much. There's no other mechanism to argue about doing anything. And so it's just a matter of figuring out, well, what could move the charges? Why do electrons and protons move? And so you could understand that you know certain rules about how the movement happens. So one of the rules is, you could argue, is that if I was to make the nucleus, okay, out of just electrons and protons, and that is just recognizing that, for every electron, there's 2 protons. Okay, so you have a simple rule that's going to help you navigate the truth. And it's just a matter of where to place these. Since you have 3 dimensions to work with, I'd argue that that's how you will place the 4 to 1 relationship. But that would be a nucleus. A nucleus would be something that has more protons in it by 2 to 1 relationship, and that the electrons are on the outside of atoms. Okay, so we know that if I make more complex atoms like carbon and oxygen and different bigger molecules, that I basically have twice the number of protons in the nucleus, and then I have the extra to make a balance of electrons to protons. Those are the ones on the outside. And so we know that photons, I'll represent them with this stupid squiggly crap, that they interact with these electrons, and that there is no real hard evidence that they do much at all to the protons. So this is sort of an interesting phenomenon, is that they basically interact with the stuff on the outside of the atom, the stuff in these orbits, these distances from the nucleus, you could argue. All right, these energy levels, as they call them. All right. And those energy levels, I would argue, are just represented by how electrons would stack. Okay, if you were to stack electrons, you could understand that they avoid each other. And so if you did stack them, they would alternate their positions, okay, and they would be a set distance from each other, because they're going to balance each other's pressure. Okay, now I'm still arguing what the pressure is made out of. So I would argue that you could figure out that this photon stuff has something to do with it, because it moves these electrons. And by moving the electrons push on each other with their force, their repulsive force. And so somehow the photon force is probably the same force that's between the electrons pushing them together. These are easy enough to make inferences, that's probably the mechanism. And so, that's the mover, is the stuff the photon is made out of is the same stuff that's in between the electrons, pushing the electrons away from each other. So it's essentially the repulsive force between electrons. And that you can add to that repulsive force by pushing photons into a surface. You can add pressure to the electrons. And if you add enough pressure, you can make electricity. And if you add enough pressure, even more pressure, you can create ions. You can start shooting electrons off the surface. So you know that the photons are key or integral to pushing these electrons around. And so it's really just finding a sensible mechanism, describing something that achieves that. And so you start thinking about, well, okay, it's little bits moving the speed of light, and so you have to think about that for a while, okay? And then you just have to figure out, well, how you can get how you can cause collisions, okay, and you can cause motion, but it doesn't give you these, doesn't create the attraction between the protons and the electrons. So it takes a little bit of work. I mean, obviously I can't do the entire process I went through over a period of years to fall on the truth, and you fall on it, you trip over it. It's always sitting there being kind of obvious, and with a little bit of time, and a little bit of drawing and then simulating. I mean, it was key to figuring this out was one of the guys working on the simulation actually saw it before I did, and the key function, because I was reacting as if, well, you can't create any mechanism that's too that's going to bend somebody's capacity to understand or accept, because it's a little bit too much of a function. They'll just reject it because they're going to say, well, that's too complex a mechanism to just arrive, okay, without a God or something. All right, so the simple argument is that this is how simple the basic physics is. So there really is just electrons and protons, all right? It's all you need to make atoms. You don't need anything called a neutron. And it'll become so obvious, like once you know that there's just electrons and protons, again, it gives you answers to all kinds of problems like the strong force. Because somebody, even just observing Maxwell's equations and the creation of charges, should have been able to figure out that if I want to get two positive charges close together, all I do is put a negative charge between them, and I can get them really close together. Now, it seems kind of ridiculous that I could be the only person in those 200 years that could have made that statement and say it's kind of obvious if I have charges and I want to get two positive charges close to each other, I just put a negative charge between them, and nobody could think of that. And it's obviously what's happening in the nucleus. That's exactly what's happening. For the two protons, there's one electron between them, holding them together, locking them together powerfully. And if you knock that electron out, you'll get a powerful repulsion. That's the strong force. There is no strong force. The strong force is just a consequence of charge. All right, so anyway, the simple argument is that all there is these electrons and protons, and all there are three simple rules for their interaction based on the fact that there's two kinds of force in the universe, two kinds of little bits moving the speed of light. And so those little bits represent photons. So if I have those little bits at a frequency, I should have done them in blue because they are blue. The photons that we see are electron force, so they're always the blue force. And when they have this specific frequency, okay, they will cause, all right, there to be an effect in an atom because atoms have a specific size. And what you're really going to do is you're going to shoot an electron to create electricity, to make a photon mean something. The photon needs to make electricity. It needs to cascade an electron. That means it needs to efficiently push electrons into each other so they basically move force from one end of the snake to the other end. And that becomes what we call a photon because the energy is moved in one direction. All right, and so that's the simple argument, that photons are just discrete bits at a distance. So it's a period between events, a period between collisions, pushovers. So a period between collisions can mean you can create a different effect. So it's a tipping point argument, right? If I throw things at the right rate, I'll tip something over. I throw them at the wrong rate, I won't tip it over. That kind of simple argument. All right, so there's this force, and there's the two varieties. And the simple argument is if an electron force hits an electron, it will push it if there's no force going this way already. So if there's nothing stopping it from adding force, it adds it. So if it already has a little bit of force pushing it, then the second one will stick and it'll go twice as fast. And its speed is always going to be something like 10% of the speed of light, or some kind of percentage, 5%. So whenever it hits an electron, the force will now be going substantially slower than it was going before, unless there's a whole bunch of these things already on the electron. So if the electron's already going really, really fast, then the force doesn't lose as much energy. But if it's going very slow, or not moving at all, then the force is going to be losing a tremendous amount of time because it's going to be moving slower because it's pushing a big giant electron. It's a simple argument. All right, so if there's no force, it just adds and it gives its momentum to the electron. The momentum is conserved, and so you end up with a heavy thing going slow. You start with a light thing going fast. Now, if there is an opposing force, that is, if there is a force already going this way and a little bit hits this way, then they're going to reflect. That is, one of the force bits on this side will leave, and this one will reflect, and that'll be essentially just giving the energy, neutralizing it, and so the electron will lose 1 unit of momentum, perfectly consistent with energy hitting in the opposite direction and canceling energy previously acquired, sending it back, essentially. So those are two reactions. So you have one is absorption, second reaction is a reflection, and the third reaction is as if the electron force, the proton force hits an electron, or if an electron force hits a proton, it goes in, okay, the opposite, and it comes out the same. So it goes in red, but in this case, and then it comes out blue. Okay, it's converted. And with that simple mechanism, you've got all you need to create every function of charge, because what you'll basically end up with is this blue object, no matter what color hits it, it only emits blue. Okay, that's it. That's all that comes out. And the red, blue comes in, red's going to come out, so it only emits red. Okay, so you have two perfect emitters, positive, negative, north, south, however you want to look at it. Those are the magnetic monopoles, and they are the electric monopoles. They are the poles that give all of the other polarized functions their functions. So if I put two of those together, you could understand, create a neutron. The neutron is going to have a polarity, and from a distance, it's going to look polarized. Wrong cap on the wrong thing. So if I looked at it from a distance, okay, I'm not going to see this red and blue thing. I'm going to see just purple, okay? But the closer I get, the more likely it is I'm going to see that. So that's just a fact. The colors will blend from a distance. It'll look neutral, so that's why they called it a neutron. It's because it looks neutral from a distance. But as soon as you get close to it, you're going to start seeing that it has a distinctly positive and a distinctly negative component. And that will become obvious and such. Write caps on these things. Right. So I think we're already to the point where I can just make that simple argument. That's all you need. I mean, once you have this, you can build atoms, because now you have your dipole. And your dipole is what's going to create your capacity to make a magnet. Right now, if all these little dipoles were pointed in different directions, well, then you know it's not going to be a magnet. But if I can get all these little dipoles to point in the same direction, then it becomes something magnetic. So that's just the basic rule of domains. That's what you can hear in iron, when you make the domains all switch. So it's clearly just pointing out that all you're doing is making the nucleuses turn. The nucleuses have the protons, so they do the turning. They do the changing of position to orient their dipoles in predominantly one direction. So, I mean, it's not going to be like every single dipole, every single neutron is pointed in the right direction. It's just that you have a lot more pointed, in one direction than you do all the other directions. And so the net effect is magnetism. That's why you can make any grade of magnetism. You can make a very strong magnet, or you can make very weak magnets, depending on how much you align those nucleuses. Not complicated, really. All right, that's probably enough for a moment of pause. Yeah, I'll pause for a moment. Let's see if we have volume. Maybe I didn't check the volume. Maybe I didn't check something and nothing's working. All right, so some snark comment, I guess. Study natural law with Mark Passasio. What the fuck does that even mean? I mean, why do people post shit that just incomprehensible shit? Who am I supposed to know who Mark Passio is? Passio? Am I really? You really think I'm supposed to know who that is? And what's all these retracted messages? What the fuck? Yeah, what the fuck? See if it says anything. Can I see the retracted message? No. Okay. It just doesn't make much sense, so thank you for being usual. Useless. This audience participation thing is just so difficult. Oh, the whole word natural law just sounds so oh, it sounds so religious or something. You know, like it's such a forced thing. You know, Mother Nature kind of. It just doesn't sound right at all. Natural law, whatever the fuck that kind of crap would be. Ooh, it gives me the creeps anyway. It's science. You know, science is a nice word. I mean, it represents something. It represents, you know, the fact that your intention is just to find factual statements you can make. That's science. Can I describe? Can I make a sentence that's a fact describing how something works? You know, and the simplest science is, you know, water is wet. You know, you invent the word wet to describe exactly what the thing is, and then you're guaranteed to be right. And then you go on from there. Let's see. Can you shoot electrons? Well, of course you can shoot electrons. I just pointed out how, you know, all you need to do is create this pressure circumstance. So, you know, if I had a circumstance where, you know, there were 2 electrons on either side of a proton, for example, or, you know, that'll work just as well. So I have 2 electrons on either side of a proton, and then and if I hit this proton out with enough energy quickly, see if it happens quickly, like gamma ray, the electrons never knew it happened. They couldn't stop it from happening because these forces are completely timed. They need time. You know, time dependent means from the AI's point of view. Time dependent means that. Why do you keep retracting comments? I'm going to just block you if you keep doing that. All right, because I find that really offensive. It's just saying shit and then you're taking it away. So if you do that one more time, I'll block you. Okay, just letting you know. I'm not going to put up with that shit. I mean, having it happen once is one thing. Having it happen 5 times, there's 5 times you have to retract your fucking comment. 5 fucking times. Maybe I just block you now, but what the fuck is that? I mean, there can't be any good reason you're doing that. Well, I'll give you one chance to give me a good reason you're doing that, you fuck. You weaselly little conniving cunt piece of dirt. You shit. You garbage. I mean, can't you just grow the fuck up and try to be a decent, neurologically coherent human being? Can you do something fucking reasonable instead of lying and sneaky and bullshitty? Fuck. Alright, anyway. So if I shoot this proton out with a high energy photon or some other mechanism, you can easily understand that these 2 electrons are going to fly out of here because all the pred force on either side is going to turn to blue force between them. So it's going to be an insane amount of pressure created between the 2 electrons, and they're going to fly away at a very high speed. So of course electrons can be shot. And that's the whole point of the photoelectric effect, is that what you're basically doing is when you hit a surface of atoms, the atoms has a bunch of electrons on the surface, right? You can understand this, right? This is what a surface looks like, a bunch of electrons. And so the photon pushes on this electron. That pushes in, okay? And then the electrons on the 2 sides push out, right? You could understand. And then this electron's now going to push out because this one pushed in. You see what I'm saying? So you're going to transfer this motion. And the real trick is what, you know, electricity, you're transferring the wave, so to speak, the push this way. You're moving the electrons this way. You're pushing them thinner this way. They're getting fatter this way. Okay, but their speed is still low enough where they stop and go back. And, you know, so they're pushing on the surface. Like little piano keys are popping up. Pop up, pop up, pop up, pop up. That's electricity. But if I give it enough energy, okay, if I push hard enough squeezing, I end up pushing the electron, it flies off and keeps going. I eject it from the surface of the atoms. And of course it has every capacity to return to the surface. But it may not, because I gave it escape velocity. So if I give it enough velocity, it's gone and it's not coming back. Alright, because conventional physics, I believe, says they can. Well, again, it's Of course, you can push electrons. I mean, the whole argument about all of the motion that matters, magnetism, electricity, all this whole idea of why you would even bother sending force from one place to another, why you would send a radio signal from one place to another, is to push on electrons. That's the whole point. You're not doing it to do anything else. All you're going to do with your force, your speed of light force, is push on electrons. That's the whole ambition. Okay, that makes sense. I can see the time dependency in play. Yeah, well, like I said, the time dependency is a tricky concept now, but now I have to say it some other way, because physics interprets time dependency to mean time variant, that somehow the force varies with time. And that's completely bullshit, right? That's not, no, time dependency is what consistent forces do, constant forces. So because they're cheating, and they're doing their Leibniz thing, they have to bend the meaning of all these words. So it's much like Leonard Susskind calling gravity an anti-convergence. Why would you call it an anti-convergence, right? I mean, an anti-divergence. Why would you call something an anti-divergence when the simple term is convergence? Right? It's just their sneaky bullshit physics. All right. So they measured the electron using 1/2 mv squared. Right. They did the classic Lewin. Everybody does it. It goes right back to these arguments about the pendulum with the 1 to 3 mass. They do this. This is what they actually draw on their board. mv equals 1/2 mv squared. They do that. And now they start doing their processing, they're crossing outs and and that's how they end up creating this bizarre nonsense formula that states that you can make positive, that you can create free momentum. Yeah, so I'm just saying there's a classic video, with Helmholtz coils, and where they put electron beam inside of a glass tube and spin it in a circle, okay, and they can make the circle big or small and all that kind of crap. And that's the experiment where they're actually calculating the mass of the electron by predicting, assuming how fast the electrons are moving, which they can't measure. All right, and so the whole thing is kind of ridiculous. So they're just going to do a bunch of math to tell us what the mass of the electron is. But yes, it's based on their calculation is assuming that the velocity squared part. So you can understand that if they think the energy of the electron, so let's say the energy was this big, a number, and they think most of that was caused by the velocity and very little was caused by the mass, you can understand how they've way underestimated the mass of the electron, because the mass has to be very small because the V number is being made insanely big. So they made part of the energy huge from the V portion, and the mass portion is tiny. So yeah, if they would have used MV to calculate, the electron would weigh 1,000 times more. It would probably weigh as much as a proton, that's the irony, or half as much as a proton. They'd be a lot closer in masses if they had used MV. I wish I was more. I wish I wasn't. I wish I was more interested in doing mathematics, because I'd like to redo her equation without the MV squared and see what number I get for the mass of the electron. Critical thing, really. And it's clear that there's, the electrons are stuck in the nucleus, so there's good reason to think, protons. So there is good reason to think protons are heavier, and that's why they can't be, they can't be extracted as easily, they can't be moved as easily. And so that's why they're stuck in a nucleus. Yeah. But there might be another reason why they're stuck in the nucleus that I'm just not aware of. But once they are stuck, the whole idea of the electrons on the periphery, they're really easy to move. the nuclear electrons and protons are obviously very close to each other, so they're very locked. You have to hit them with very high energy to break a nucleus. So it's only the external electrons that are easy to kick out. Alright. So we're almost to the point where, yes, we'll argue the Bohr model crap now. But I mean, it's clear that mv squared has ruined physics. Okay, so that's, you know, but I can't get anybody to pay any attention to that subject. But it's clear, it's just wrong. It's just a silly notion. It doesn't take 25 times the fuel to go 5 times as fast. Going 5 times as fast does not do 25 times the work. Just zero evidence of any of that kind of crap being true. And then Bohr and Einstein just made everything worse. You know, with their silly, you know, I don't know why even. I mean, Bohr especially, I guess, just I have a real contempt for, because he sounds like a religious shithead. He doesn't even sound like a scientist. I think he wanted things to be too wooey for us to understand. Things to be beyond human comprehension, because that's the only way God can make sense, is that it has to be a system that's beyond comprehension, because only a God could understand how it works. You know, and that's the bullshit. So anyway, I mean, this classic, and again, Rutherford had said that, you know, there's electrons in the nucleus. So, you know, Bohr took Rutherford's description and basically just ignored it, okay, and made up his own idea of a nucleus. What the idea would be is that they're all locked together in that 2-to-1 relationship in the nucleus. So the nucleus, from certain positions, you could argue that from some places the nucleus is going to look proton, and from other places it's going to look electron. And it's going to do that in this polar kind of way. And it's not going to be just a dipole, right? The nucleus could be a tripole. You know, it could have more than one pole. And in this case, it has a pole going left and right. The north poles are this way, and the south poles are this way. You know, so you can understand that the polarity is going to have a complexity to it. And so that's going to mean the magnetism created, that is how it's going to orient other particles, and where they're going to be is going to be different. So you know the electrons are going to be here and here, where the positives, you know, where they can see the proton part. And it's going to be less likely to have an electron here, because that's the part where there is an electron. And so your next electron has to be further away out here and out here, because, you know, it can't be too close to this one, and it has to, you know, and so it gets all balanced. So these are the ones in close, all right, and these are the ones out further. And there's just no reason, okay, to think they're orbiting. They don't have to orbit. They're magnetically fixed. They can't get any closer because of the magnetic effects. You know, the propulsion and the attraction are dictating they can't do that. If this tries to move in closer, it gets closer to these two electrons and they push it back. So nothing, you know, everything ends up in a stable condition where there's a balance between what it can see. As something gets closer, you know, it's going to end up seeing that polarity that I talked about before. The dipole ends up becoming visible. You know, when you're far away, it's not visible. When you get closer, it's visible. And especially when the electron is, say, here, well, let's say the proton is in front of, an electron is in front of a proton, you know, the idea is that it's going to obscure the proton, you know, pretty much completely. You know, the closer you are to this, the less you can see of that, and the further away, the more of that you see, in the sense of the effect, when all you have to do is move a little bit and you'll see it. But you can't move any amount here. It's got to move a huge amount when you're close, because it's right in front of you and it's blocking, and you can't see around it. From a distance, you can look, oh yeah, I can see it. Oh yeah, I can see it. And so as soon as you see it, then you start reacting, and that's why things fall apart when they get further apart. So as things get further away from each other, they can't see each other the same way, and they start doing all of this stuff. So they can't match. You know, they can't just crash into each other because they keep missing each other. because the force is constantly pushing them all around. Constantly. Alright, so obviously, so this silly model of Bohr's, right? I remember when they drew this as, I keep, equating this to my reaction when I first saw it as a kid, and I was just like, how can people believe this? Alright, so their idea is that you have two nucleuses and you're going to share this electron. And so the electron is going to be doing this horse shit. And I mean, I knew how complicated that was already because it already explained orbits and how, it's complicated. There's one little place and you have to go the right velocity, and if you're not, you're a little too fast, you go out. You go a little too slow, you crash in. Lots of rules about this whole orbiting crap. So how could this electron be doing this, especially here, right? I mean, what's this funny distance? Right, because these two protons could be almost any distance from each other. Right? They could be really close, they could be further apart. I mean, how can it do this? And how would that keep it together? How would an electron swirling around, going to all these places, how would that make this proton hang around? Stay the same exact distance away. It wouldn't stay the same distance away. It'd be flying all over the place. So it doesn't make sense on so many levels. And you're saying, how did this persuade everybody? This silly description, of a shared electron that's flying all over the frickin' place. So, I mean, the obvious fix to that model, is just the simple explanation that, yes, here's your two nucleuses. When you're sharing electrons, you're literally sharing them. They stay in those positions. So this atom has electrons, this atom has electrons, and these two atoms are sharing these two electrons. And they're literally sharing them. They stay in these positions. They have to stay in these positions, or they can't share them. And all of these other forces, the two electrons are now tied to each other, so now their electron pressure is tied to each other. It works perfectly. It makes perfectly good sense. Now if I push on this atom, it's the same thing as pushing on this atom. I can't push on one without pushing on the other, because they're pressure tied to each other. They're, it's perfect explanation. It makes perfect sense. I'm the only one? Alright, so Dark on this. I really like seeing your drawings because it provides explanations to the physics. I don't understand how anybody can do physics without drawing it, frankly, but yes, I don't understand how modern physics can make sense with all these convoluted equations. Well, I obviously have a contempt, for bad math, but MV squared is really bad math because that's using word games. I mean, they turned something that was really simple, 9.8 meters per second squared, per second of extra velocity, right? So that's clearly just a unit, 9.8 meters per second, okay? A unit of a change in your velocity. It's just a change, an amount your velocity changes. And it happens every 1 second. That's a really simple formula. It's not F equals ma. That's not, F equals ma does not equal that. Okay, so that's the big lie. So when they use math, it's just a lie. And like I say, the 1/2 mv squared doesn't work. I mean, they talk like this is proven, or it makes accurate predictions, or it doesn't work at all. It's saying things with two different momentums can do the same amount of work, which doesn't make any sense at all. Momentum is momentum. Momentum does work. Momentum pushes springs. Momentum is weight. How can two things that weigh the same weigh different? I can't make two things that have the same weight weigh different. How can I do that? How can I have a scale that makes them weigh different? It's not possible. I can't make that scale. So it's really stupid. Alright. Orbiting electrons can't work the way Bohr modeled. Yeah, well, of course. And then they made this argument that, the worst one, okay, I mean, to me, they're all bad arguments, but the one that was the silliest is they think the moving charge thing, right? So all the electron has to do is move anywhere, and somehow it's creating a magnetic field, or an electric field, and that it's using energy to make that field. That somehow it has batteries, and it's, wearing its batteries down to make some sort of field. And it's just, it's just so wrong. So they're claiming that it can't be an orbit. That's why they have to have quantum orbits, magical orbits that have no friction. Is because somehow the electron needs to be in some sort of special orbit where somehow it isn't producing, a field that it has to create. Like it's making photons or something. And obviously it's not. So they would argue that this can't happen because it's going to slow down because it's making a magnetic field. And it's like, no, it isn't. You don't have any evidence that it's doing anything like that. Because what's really doing it is this motion. The motion going this way, is the only motion the electron has. It doesn't have any other motion. And it's that motion that creates the inducting field. That's the motion that creates photons, that creates induction. That's the motion out and the motion in. So when electrons move from one place to another out, or they move out, they're doing that. So they got that part right, where they talk about quantum energy levels, because those are just logical positions where if you're going to start piling electrons on a surface, you have to pile them where the electrons aren't, because the electrons hate each other. So again, you're just basically doing this simple geometry, saying, if I have 2 electrons here, then I have to go here, and then the next electron has to go out here, and the next one here, next one here, next one here. And you're just building geometry. Yeah. So what else do I have to say? Yeah, so again, it just doesn't have anything to do with any orbiting. They're magnetically locked. They're locked in charge relationships. So I could take a bunch of, this is the stuff where I guess I could demonstrate it. I could go to the trouble of finding 2 pieces of glass and then put magnets underneath the 2 pieces of glass, where they're flat and they can't flip. And then I could show you that, yes, I could actually place magnets in a configuration where if I could poke on one magnet, the other 3 magnets will move. But they can't crash into each other because they can't flip. Yeah, I could show you that. I could show you magnets looking like charges, behaving like charges, because they are. It's all the same thing, and the only thing that makes magnets different is those dipoles can flip. Neutrons can flip. It's just, it just isn't. It's so much more logical. I just don't know why people find this silly orbiting theory at all appealing, because the complexity of it is insane. And you're just saying all the electrons in the atom would start interfering with each other because they'd be in all kinds of wrong places. They'd line up like Jupiter and Saturn, and they're all lined up in the same row. Well, if they're repulsive, that wouldn't work, would it? If Jupiter was repelling Saturn and was repelling neutron, whatever it is, neutron. Anyway, you know what I mean. If they were, then obviously they couldn't line up, and they'd push each other out of their orbits, and the whole thing would get all screwed up. So obviously you can't have a bunch of electrons swirling around in the atom, because they would end up not having equal pressure anymore. There wouldn't be constant pressure between all the electrons all the time if they were orbiting. And that constant pressure is essential to the weight distribution and the way that you can poke on one electron and move all the electrons. And that's the theory of motion. That's the theory of, that's the medium that's creating your waves. So if you want to have waves in an ocean, you have to have water molecules that stick to each other. Well, the same is true when you want to have waves in atomic structure. You need pressure to force the electrons to be right next, too close to each other, so they can feel each other constantly pushing on each other, applying a pressure to each other, and they have to balance the pressure with every person who's pushing. All the pushers, the pressure automatically has to be balanced, right? You could understand you couldn't push something with more force in one direction than the other directions, or it'll move in that direction. So the only way it could stay in one place is all of the pressure from all points has to be the same pressure, or it moves. So I mean, obviously it ends up finding a balanced position, a position where it can balance the pressure between all the other electrons. And you can't do that with an orbiting model. It doesn't happen at all. So there is no way you could transfer electron pressure. And transferring electron pressure is it. That's the whole subject. I mean, frankly, that's electricity and that's induction. Again, the simple argument is, if you could understand that, yes, if I'm pushing under the water, okay, this is the electron I pushed on. So I'm sending electricity through a wire. I pushed on this electron. You could all sort of understand there's all these other little combining electrons. But you can also understand that, yes, I'm sort of compressing the atom. And so this electron pops up, right? And then you can understand that that's going to push on these other ones. And when they push, this one's going to pop up, and then this one's going to pop up, and then this one's going to pop up, and it's going to do it in this progressive manner. Okay, and that's electricity. And what's the pushing mean? The pushing means it's doing this to the environment. And what does that mean? Well, if there's a photon coming in and it has a frequency of x, okay, and it hits an electron moving out, it means that its frequency is going to be x minus. You know, it's going to be a much smaller frequency when it leaves. You know, and that smaller frequency will mean the higher frequency, I guess I should say, right? Lower or higher, not smaller. Okay, so I use the wrong terminology. The higher frequency means that you're hitting something, like with baseballs, you've got them closer together, so you're more likely to tip something over. You don't have more energy technically, but you have a capacity to break things because you're going to apply all the energy at once almost. So that's why the higher frequency has an advantage. But anyway, that goes off and hits another surface and just repeats the pattern on the other surface. The other surface ends up getting hit with the same pattern, and it just duplicates the flow of electricity. And that's induction. There's no new photons created. It's just reflections. I mean, right now, a magnet sitting on the ground producing magnetism, right? I mean, there's a little magnet here holding a stick. See, a little tiny magnet. All right, and you know, it's holding that little wire. It's doing that all the time. It's all the time making this thing stick to it, you know. And so how does it do all that work? It's doing work against gravity. It's keeping that piece of metal from falling, and it's holding it up. And so, I mean, the simple argument, that's real work it's doing, right? There's no way of getting around it. That's real work. It's because the magnet doesn't actually do any work. It doesn't do anything. The external environment's doing all the work. So magnets are just sitting there, okay, being polarized. Guess this pen is no good, so we'll throw this one away. Okay. Didn't go very far, but this one's not much better, but it'll have to do. All right. And so all it's doing is, you know, purple is coming in, you could argue, right? The red and the blue. And the fact is the magnet essentially, okay, is going to do the same thing it does with charges. It's going to just filter that result. And it's just going to make the blue, okay, primarily coming out of this end, and the red primarily coming out of this end. Now, it's only primarily. It's still purple. It's just not as purple. It's more red at this end and more blue at that end. And it's a real pattern it's going to see. So we're talking about the arrangement of electrons and protons. And what the fact is the arrangement's going to be something like this, something like a bullseye. Okay, where in one case the blue will be the first ring, and in the other case, and then the red is the second ring. All right, in the other case it's going to be red and then blue. So you can understand that it's something that can see, okay, this is a push, the blue is a push, and the red is a nothing, a neutral. You can understand that depending, if I'm polarized, if my eyeball is doing the same thing, that is, if I have a red center looking at this, then we're going to be attracted. And if I have a red center looking at this with a blue outside, then we're going to be repelled. And so it's just a matter of me, if I'm iron or I'm some substance that can become magnetized, polarized, my polarization matching the polarization I'm facing. And that's all that's going to happen. So that's why it only works on, magnetism only works on magnets, so to speak. Things you can polarize. Things you can't polarize, they ain't going to work on. Can't mean anything. The pattern can't be seen because they don't have the eyeball. They don't have the opposite pattern to match the pattern the magnet's creating. But the magnet's not doing any work, right? It's at equilibrium with the universe, so it's just filtering. It's just changing the force in terms of its arrangement, but it's not changing it in terms of its volume. So it's not making a force. It's just changing how the force is distributed based on its positive and negative polarity. It's changing the polarity of the force. I guess is the way to say it. Yeah, it's the way I'm going to say it. Let's see. I don't know what that is. Orphan polemic. I don't know, polemic. Polemic. Yeah, I don't know. But good enough. It's an actual icon, so that's something new. A person with a real channel. Oh, I guess this other guy has an icon. Sorry. Yeah, Dark Endless has one too. They're just hard to see, so they're very small. But anyway. Alright, so now where was I? So I did get to polarization, magnetism. So yeah, these are all the key functions, and I'm just saying. So this model works. It explains it all. Very uncomplicated, very mechanical, very push-aversy, and you can't get people to even consider, letting go of the, wooey mush of, Bohr's religion. And that's all it is. It's Bohr's religion. We might as well say we're back to fighting castless. We're back to just making a Darwinian argument facing the religious kooks. It's the same circumstance. They're attached to their wooey explanation, and they just don't want to hear a simple explanation for why things are the way they are, how they got that way. Because it's just not it's not human aggrandizing enough. It doesn't please their egos, I guess. But these are all these are the simple subjects. Now you can go on to the double slit experiment, but obviously that one's going to take even, it's not that it's more work. I mean, it's the same idea. It's just electrons moving, and you're moving photons through a filter of electrons. And you know that the electron filter is going to change the photons, and it's not going to be all that complicated again. So I am waiting for that stupid math and science guy. He has a video titled, yeah, I should be able to pull that up actually, but whatever, I don't feel like it. Yeah, it was titled, let's see, something like, do molecules have color? Alright, because this is like the argument I made about sound. There's these certain arguments you just, oh, gee, they were so close. Like, they should be able to test this idea that, all sound is created by sonic booms. So something has to move faster than the speed of sound to create sound. So something can't make a sound unless there's some physical machine, some piece, moving faster than the speed of sound. Which I find quite compelling and interesting and truthful. As a statement, it just seems so obvious that's the way it's working. That's what gives something, just like with the electrons in the wire, they need to have enough motion to get on the frictionless road. There's a road that's frictionless. So if they go at a fast enough jerk, they can, without any friction, without spreading their energy. Their energy won't spread to the side, right? It's like going through the magnet really quick. If I had a magnet, a horseshoe magnet, I went through it really quick, nothing happens. I don't get slowed down. But, if I go slow, I start creating all kinds of interaction with the magnet. But if I go quick, no interaction. And that's the secret to sound, is that the atmospheric atoms are pushing on each other's electrons. So all the electron pressure is being dissipated between all the atoms. So you push on one electron, the idea is you push on all of them. And that's what you need. You need to push hard enough where the energy keeps going straight and doesn't go sideways, because it won't. You're not going to feel the other electrons, because you went quickly enough that you fooled them. They didn't see you, because you went fast enough that there wasn't enough time for the force to go back and forth and tell the other electrons that you moved. See, the electrons are vulnerable. The electrons are communicating each other with a force going back and forth. And so if you move one of them quickly, the other one won't know right away, right? Just like with us and the sun disappearing. It'll take a little while before it knows. So the idea is that any force that's going to communicate your energy, that is force where this thing's motion is going to be transferred to this thing's motion, it takes time. And so if you have the motion quickly enough, you've broken the connection. And now you won't be jiggling this. This motion won't jiggle this. And that's how sound moves efficiently, so much more efficiently than just a vibration. So if I just have a vibration, I just do this, that vibration doesn't go very far, because it's not quick enough. It's not frictionless. The vibration's getting dissipated in all kinds of silly motion of all kinds of atoms. I don't want a bunch of atoms jiggling all over the place. I want to just push on the electrons. Quick. Then it makes a sound. So if I can get it to go quick, 500 miles an hour, whatever it is, it'll make a sound. A little sonic boom. Sound isn't just waves, so fuck you. Okay, you could say shit like that, but that's just baby talk anyway. I'm sorry, sound is just like radiation or anything else, okay? This motion, all right, is real motion. It's moving the air molecules. The air molecules are essential. There's no sound without the air molecules. So, what's your argument that the wave is elemental? I mean, you do understand that waves, even in water, it requires that there's a motion this way, right? And then the pressure, because it's an uncompressible liquid, goes up. And so there's too much pressure for it to continue moving this way, the molecule of water. So it has a choice. It goes down. Well, down is the floor of the ocean, so it's not going to go that way. So it has to go up, and that's what creates the wave. I mean, there's a real mechanism. Wave isn't just, oh, it's waving. It's an elemental function waving. No, the wave is made out of a whole process of action. This has to happen. This is what a wave is doing. Okay. It's a process. So you can't just say, oh, it's waving. I mean, that's not physics. That's not science. And again, the idea that wave is an elemental function, that somehow things elementally wave, is just nonsense too. So bullshit. Sound is particles of air, molecules. Okay, and again, the electrons are pushed into each other by the air pressure. So the higher the air pressure, the more efficiently the sound moves. The thinner the air pressure, the weaker the sound, the less efficient. And and so all of it is just like sonar and all this stuff in water. It's doing the same thing, in the sense that you really are just pushing in all directions on a fluid. The fluid's uncompressible. Air is pretty much, in some respects, it's a hell of a lot more compressible than water. But you're using so much less force, in air, so you can have much quicker, higher frequencies in air. So, it works fine. So there's just no reason to say You don't have to believe that waves are fundamental. I'm just saying that waves are always a mechanism that requires a medium. All right, and that's how things, But that and it's not even like there's something magical about the medium. It's just that you have to follow the movement. What's moving? There's physical little things moving. Nothing, It's not like some kind of magical process. A wave, in a sound wave. It's real little molecules that have to move and bang into each other. All right, so anyway, she was breaking my whole continuity of making the argument that, so it's just like the electricity argument in the sense you need enough speed to make electricity, and then you need enough speed to eject, make ions. Well, the same argument is true for sound. You need enough speed to create the efficient motion, where now you're pushing electrons into electrons in a straight line. The slower something goes, like I said, this is just so critical. So if I had a gauntlet of electrons, all right, you're going to push a proton through it. It's really easy to understand that if I push slowly through it, these electrons are going to be attracted and they're going to pull in. Right, so then and then anything they're attached to is also going to pull in. So I'm going to be pulling and moving a lot of other stuff. So there's going to be a lot of torque on my proton, right? It's going to get torqued. It's going to be pulled on very rigorously because all this stuff is moving, and its motion has to cause all of that motion. And the simple argument is, if I make this go quickly, though, through this gauntlet, there's not enough time for these forces to interact with each other and for this to affect that and move that, and this to affect this and move this. So this isn't going to be pushed this way, and it's not going to do all that jiggling and wiggling. And so that's where you preserve the energy, because you're not losing it to all these peripheral influences. So by going quickly, you get rid of all the side stickiness. So it's like the clay and bullet argument, right? If I shoot a bullet into a lump of clay, the track is really clean until the bullet starts slowing down, and then it gets really messy. Okay, so the idea is when the bullet has its highest velocity, it's a nice clean track because it's not sticking to the clay at all. But the slower it goes, the more the clay can start sticking to the bullet, and the more it's clumping, and the more it's dragging, and the more it's... So the more you're dissipating the energy. So that's kind of like how energy is dissipated when you shoot a bullet. It's like a Christmas tree upside down, right? Yeah, like a Christmas tree with little ornaments on it and blah, blah, blah. But I'm just saying, that's the slower you go, the more energy you're dissipating to the sides. And the faster you go, the less you're dissipating. So it's the same as the friction argument and rolling things in friction. The higher the speed you're rolling, the less friction. The lower the speed, the more friction. Same arguments hold. I mean, all of this works. And it's so annoying to have to spend 10 years arguing for this much simpler, sensible, easy explanation. And... just running into less belligerent people who just say no because I'm saying it, and not much other reason. If Sean Carroll suggested all of this crap, obviously it would be received seriously, and they would all have to argue it and explain how Sean Carroll's full of shit and an idiot for suggesting it, and how it doesn't fit with something. They'd have to make a real argument. And that's what's missing here. It's just the fact that you have to be a show physicist. You have to be somebody with standing in the community to ever make any argument challenging any of their established notions. But even when you do that, that's the other part that's so disappointing. I mean, Steve Mould made a video and basically said the law of the lever doesn't hold. That somehow the kinetic energy theory is better science than the law of the lever. And then Veritasium made that silly argument about electricity and how all electricity travels through induction. When obviously it travels in wires. It melts them, for fuck's sake. I mean, there's electrons moving, and it's only incidental that the electrons on the surface move in and out. That's the part creating the induction. That's only a symptom of the electricity. But you have to have the motion inside the wire, or you're not going to have any inducting effect. But he got away with it. He said that shit, and most people just bought it. And a couple of people make a video saying, no, I don't think so. But that's it. That's the end of the conversation. So that's the state of the science is really so lame. It's just groupthink and populist. You know, it's the absurd, you know, how whatever that that statement is, you know, the absurdity of something or other that somebody made some kind of phrase. But I mean, yeah, it's just, you know, people are just this shiny badges. You know, shiny badge means something is right, and not a shiny badge, it's wrong. Let's see, saying that everything is wrong doesn't provide the details of how the physical universe works. Seems like a lazy attempt to fix the mess that physics currently is. Saying everything is waving. Sorry, doesn't provide the details. Yeah. Well, I don't know. I can't. Obviously, this has something to do with some sort of, you know. This has something to do with a whole bunch of cultural changes. Okay, I mean, there's people doing all kinds of, you know, wacky shit in terms of maladjusted shit. I don't even know what to call it. It's awful lot of some sort of. I don't even know how to. You know, it's hard to blame it on something, but it's just like, you know, there's just so much. Like, you know, men aren't men, women aren't women, you know, that kind of thing. They're all like resisting that. So anything kind of natural about being human is overtly rejected. And, you know, it's really all this crystalism, glitter, and bullshit that people are chasing in some ways. See, that doesn't even work as an explanation either, but you have all these holistic people, you know, who have rejected medicine and all kinds of things. So even that is strange. So it is so hard to figure out what the fuck is broken. But clearly there's something broken in terms of people have lost the capacity to reason and argue within relevant boundaries. You know, there's just no meaningful argument to be had. Alright, state of science is strange. Lots of hype going on, but nothing is coming out of it. Well, it is all wrong, so that's why there's nothing. I mean, you can't make anything out of wrong physics, you know. It's just not very useful, wrong physics. So, you know, some of it you would expect it to be quite useless. So all their LIGO crap is quite useless, right? They can't even listen. They don't even predict earthquakes with that stupid device, right? This thing is supposed to hear everything. And apparently it can't hear a damn thing. I mean, it can't even hear shit on this planet. Now, it might be able to detect some underground nuclear explosion, so maybe the military has some use for it. But you haven't heard of it doing anything. I mean, you know, revealing any truth about any event that happened on Earth, you know, it doesn't say anything about anything. So clearly this is not a good device that works, you know, it's just bullshit. Absolute crap, physics. So that's not going to do anything. And then all this hype, you know, obviously the quantum computer was just, that was just too ridiculous. You know, we're going to create something where we can, you know, a qubit is basically, it's like putting a photon in a cage. How are you going to put a photon in a cage? I mean, it's just so ridiculous to even think you could make this qubit thing, this thing where it's not in this world and it's not interacting with photons and gravity and all of this stuff that's going to entangle it. How the fuck could we ever put that in a box? So the very idea that they think they can do any of this stuff is just so stupid. The thing to think that they can actually think they can detect 0 degrees Kelvin, right? I mean, they know from their own, they should be able to know from their own physics that there's no way they can make to see a colder temperature, you have to have a thermometer that can detect a colder temperature, right? I mean, it has to be too high, it has to be hot. to collect, you can't measure something, a difference, unless you can make a difference. So you have to make something colder than the thing you're testing to be able to test it. And how could you possibly make something that you know to be 0 degrees? Because what would you compare it to? There's no such place as 0 degrees anywhere in the universe. So how would you know when you got to 0 degrees? There's no way of knowing that. So again, that was just so, when they talk about, oh, we've created a Einstein Plutowski condensate, or whatever the fuck they call that bullshit, you're saying, okay, how can you think you have? How do you think you've reached absolute zero? I mean, there's no way to know that, because you can't there's no pure environment for you to make your 0 degree mark on the thermometer. There's no place to stick it and say, there's 0 degrees, let's stick it in there. That just doesn't happen anywhere. Well, anyway, it's just all... I mean, I'm just going to be curious, I guess, if this channel ever gets any kind of visibility and a few more people chime in. And we'll have to just see what the percentages are of people who say, yes, these are reasonable arguments. Yes, we should do more investigating. Yes, we should tie this up a little tighter because, yeah, we really haven't proven any of these notions. The double slit experiment is preposterously under-diagrammed. They can't even show that its actual patterns created. It really is horribly done. Obviously, the Bohr model of the active atom with all this stuff orbiting doesn't make much sense. Bent space, what the hell is that? That's not a mechanism. It's just saying space is bent somehow. Nothing is bent. Is rubbish. But yeah, what percentage? I just like I said, I had no idea that I could actually do something quite brilliant. That is, I perfectly diagrammed charge, right? With just 2 kinds of force, 2 kinds of matter, just electrons and protons, electron force, proton force. Not making too much. That's not taking too much. And just 3 little simple interactions, and I've duplicated the function of charge. I've created repulsion and attraction in exactly the proportions that charges demonstrate. And it's just crickets. Nothing. For people to not even acknowledge that, even if I'm wrong, that it's an incredible coincidence that I came up with this really simple mechanism that creates exactly that effect. The exact effect it creates is creating electrons and protons. That's what it creates exactly what they are, charges. Plus charges, minus charges, south pole, north pole. It creates that thing. And, you're saying, I mean, how could a reasonable person, even if they hated my guts, not acknowledge, well, that is fucking interesting. That you can actually duplicate charge with such a simple mechanism. And it's interesting that AI, and our artificial intelligence, that supercomputers were doing all this modeling, especially that guy, whatever his name is, Stephen Colbert, Stephen Wolfram, right? With all that Mathematica crap and all his shit, how he hasn't fallen on it. But you just say, if I gave the task, I told the computer, solve this problem. Give me a simple mechanism that creates attraction and repulsion. I mean, it really should be able to come up with this. It's so simple. I mean, it's such a simple way to make it happen. It's like Rubik's Cube kind of simple. It's not all that complicated. And you're saying, gee, yeah, it should be able to do that. And so that just sort of proves that, AI doesn't really think. Just gurgitates. It doesn't do any thinking. Let's see. There's too much attachment to mirages and nothing into anything real. That's my view on modern physics. It's a scientist's job to investigate the details and mechanics of how things work. But I'm just saying that's the obvious thing that's missing. I mean, why wouldn't all these people who are arguing with me be just as desperate for experiments to be done? Why wouldn't they all be saying, what, we have to wait for the Mythbusters to crash cars? Well, shouldn't this already be done in a laboratory? Shouldn't you have already banged all these pendulums into each other with every single difference you could possibly make? Shouldn't all these experiments have been done extensively? The fact that nobody's dropped 4 pounds 1 foot and 1 pound 4 feet. I mean, that fact is so glaring and monstrous and huge, and you're just saying, how could anybody who loves science say, oh yeah, they've tested it enough. It's enough testing. We don't need any more tests. They've done enough tests. I mean, even the double slit experiment, I mean, this is so elemental, and you're just like saying, how could anybody be satisfied? How the fuck could any of you people who care about science? Alright, so you're sending in your photons, right? The theory is you're creating a pattern. Now, the first argument is, of course, your pattern should be viewed on a screen that is equidistant, okay, from your foci, okay. And beyond that, though, the theory is that if it's a wave, there should be just as much intensity of pattern here as there is here. There shouldn't be any difference. There should be just as much pattern going here, here, here. All these locations should have the same amount of pattern. So why wouldn't you do this simple experiment? You put photographic paper here, and you put photographic paper here, and you turn up the intensity in the sense that you just let it run for a week, and see how many photons you can collect. And that'll tell you whether this is really what they're arguing or not, right? Because if there's no photons here and no photons here, well, wave theory is done. And now we can start talking about some other effect where the interaction is something that can happen 1 time or 2 times or 4 times or maybe 6 times, but that's it. It can only happen a certain number of times and create a certain amount of deflection, and that's it. The range of the deflection is just this. It can't go any further than that. And that'll tell you it's not waves. But I already know that. I've already proven that it's not waves. But I'm just saying that's something they should all demand. I mean, that's a simple enough experiment. Put a piece of a photographic plate here, a photographic plate here, run the experiment, see if you can collect some photons. Why the hell hasn't that been done? Oh yeah, the Eddington experiment from space, for fuck's sake. Why haven't they done that? I just saw the word space. It's just so bad. So yeah, if you really love science, you want these investigations, you want the experiments, you're just horny for them. I mean, literally, you're just like, ooh, I can't wait till they do the experiment. I can't wait. I just so want to see these results. I so want to see these results. And you'd be so horny for experiments. And these guys don't want to see any experiments done. They're not at all disappointed in the lack of evidence, that you can't go online and see the experiment done. I mean, even that motherfucking cunt, that stupid whatever he was, what's his name? I forgot it already. Query retard, query faggoty butt fuck. What the fuck is his name? Claude shit for brain. Well, anyway, that French weirdo. He's got the air track, right? And it's not that bad a one. And so he's making this claim that, it takes 4 rubber bands. I have to do 4 times the force to go twice as fast. Why won't he do that experiment? Not Professor Michael. Michael was charming compared to buttfuck, whatever his name is. Rousseau. What's his name? Valerie. That's it. He's Valerie Rousseau. He's got the equipment. So why didn't he do that, right? So he does it, and obviously the experiment he did had this little fake bit in it. Everybody should be able to say, well, because it's a little bit ugly, you had that squiggly weird line in the computer, why wouldn't you do it over again? And this time do it with 3 rubber bands and 4 rubber bands. I mean, if you're going to say 3 rubber bands only makes it go 1.7 instead of 3 times as fast, that's a huge difference, right? And 4 rubber bands are supposed to only make it go twice as fast, right? So that's a huge difference. 4 times as fast to twice as fast. We all should be able to see that. So why don't he do the fucking experiment? Oh, that's right, because he had to fake the first one. That's why, though it doesn't work. So he won't do it because it doesn't come out his way. That's the simple answer. It will not prove their case. It will prove my case. That's why he doesn't do it. Even with the defect, you know, we're all elastic objects that are pushing something back, push inefficiently with speed. So the faster they're pushing, the more energy they end up keeping, okay, and not giving to the object they're pushing. Well, yeah, he's run away in the sense that he hasn't made any further videos, but he certainly hasn't done anything with his experimental equipment. And that's the key point. He has the equipment to do the experiments, and he hasn't done any of them. All right, let's see what this says. There's no such thing as an absolute zero temperature. Yes, there is. So I'm sorry, you're wrong. There is. We can't achieve it, but theoretically it would exist. It's just a place where there's no force. But obviously, you know, imagining a place where there's no force would be, you know, impossible to imagine, frankly. I suppose you could sort of imagine it in the middle of a supernova where all the energy is moving in one direction, all the electrons and protons. There would be such a density of them that they would probably create a vacuum of force for, you know, some milliseconds. But I wouldn't agree that there's no absolute zero. It's just you can't sustain an absolute zero. So you could create it for a moment, but you couldn't sustain it. Like there is always something radiating like gamma rays in space. Yeah, well, the whole point is, though, is if you have enough matter between you and those rays, you could argue that you're not going to get hit by any of those rays. But, obviously, again, how do you clear the force that's already between you and your fellow electrons? It's the same force bouncing between you all the time. It's trapped between you. And so until that's evacuated, you can't be at absolute zero. And if it is evacuated, then you don't have charges anymore. So, yeah, it's a very tricky question. We'll just say it's a trick question. It goes back to Descartes. Well, Descartes was wrong in the sense that he thought this was all ether and, you know, all the planets were spinning and swirling the ether and all that kind of horseshit. So he didn't have that right at all. But he certainly was right about the conservation of mv. And that's all you have to do is follow the mv. There's a certain amount of mass moving velocity in the universe, and that is always conserved. That's the key takeaway, the big, huge conservation argument that they don't even give him credit for. I mean, he was the first one to really say it out loud, you know, assert it aggressively, that the universe is in motion, and there's no new motion, and there's no loss of motion. It's just exchanges of motion through pushing. So anyway, I titled this video something on purpose, just because I did a search on that sentence in quotes, you know, the real science of physics, right? I think that's what the title is. Let me see. What the hell was the title? I don't remember what my title of my own video. Where the hell is it? They don't even show me the title in the damn page. So they give me a page here and I can't even see the title. Alright, well anyway, something like that. And, geez, this computer's gotten so weird. Well, it's not the computer, it's Firefox has gotten weird. It's screwed my tabs, changed where they are. I don't even understand what's going on. Anyway, okay, well anyway, so it's something like that. And I put that in quotes into Google, and it came up with 5 results. And well, it came up with 10, but 5 of them were all the same book. So it was some book written about teenagers driving. Okay, and it has that sentence. That's it, 5. But I'm just saying, there's like 5 results for that sentence in quotes, and you're saying, how could that only be in 5 places on the on the internet? Those words in that order. How could that quote be that obscure? I just can't believe that quote could be that obscure. So I just wanted to see what would happen. Like if my website, I'll put it on my website and we'll just see what happens. Because it must prove that Google doesn't index the internet. You can't get to the internet. There's no way to get to it because Google couldn't care less what's on the internet. Because I just can't buy that there's only 5 unique pages that have that sentence. Those words, what is it? 5 words. Those 5 words in that order. I just don't buy it. But anyway, so it's very strange. Well, so we'll see. But that's the problem here, is that there's just no visibility. You can't get any new viewers. Can't get anybody to see your shit. You just talk and talk and talk, and it's just talking to the wind, because there's no internet. There's no way to get on the. To be on the relevant party line, so to speak. You can't get, you're talking to the wind, not the world. And that's not what the internet's supposed to be. It's all Google's fault. Turned into a popularity contest, not a relevancy contest. That all sucks, but that's nothing I can do about it, so I have to figure out some way to do this in that environment. But it's just so hard to fucking network with anybody. Who the hell can you network with? I mean, everybody's a fucking idiot. Fact. Yeah. It's just, It's like Invasion of the Body Snatchers. You just don't want to get snatched. Become part of the Borg. They're like a Borg. The Veritasiums, all those it's just so Borgy. I'm a pepper, you're a pepper, weird. They're all peppers. Yeah, AI thinks whatever's on. Look, I'm just saying it's Wikipedia. It's not much more. So whatever Wikipedia says, that's what fucking AI says. It doesn't have any brain. Doesn't have any notion of continuity. I mean, you ask it the simple questions. Like I said, I've already done this, but you ask it the simple. Do levers conserve momentum? No. And then later it'll say, yes. So it's like, well, what the fuck did you say no before for? Well, it does. The maximum speeds will be preserved, and those will be momentum. And it's like, well, then it doesn't conserve kinetic energy, and then it'll say, no, it does conserve kinetic energy, and then it'll give you the spiel why it conserves kinetic energy. And they're just saying, it's just so full of shit. It overtly contradicts itself. It's just sad. That's the state of things. Let's see. Yeah, AI takes its info from internet. Doesn't take info even. It really is just autocomplete. It's just completing sentences. It really doesn't know what the fuck it's talking about. You might be able to admit to AI it's wrong and agree with you. You might be able to admit to AI it's wrong and agree with you. I don't know what that means, but yeah, I think AI will admit that you can fool it. That it gave you a wrong answer, and it'll say, well, yes, the more complete answer is. So yes, when I said that, I was wrong. It'll admit it's telling you bullshit, which is just ironic. Frankly, it's just funny. Oh, you're going to admit you're full of shit. Oh, okay. Let's see. This is kind of curious. I just stuck these magnets and these ball bearings together. Maybe I could show that under here, yeah. So you can see there's 3 magnets holding these 3 together. And then there's this one on the top. And it's very interesting. This one spins really easy. Okay, it doesn't pull off, but it pulls off with a little bit of work. But it's not really connected to the magnets, it's connected to the balls. Okay, and it rotates though quite well. So I have to see if I can hang something that way and then spin it. Because these won't spin at all. They're really tight. I can't barely, I can't spin them without the magnets moving. So they won't rotate at all. But this one rotates freely. Yeah, it's interesting. Yeah, it's very free, it rotates. Anyway, yeah, just an experiment. It is funny that you can just be playing with something and it just say, oh, yeah, that's interesting. Why is that? Because this is peripheral magnetism holding this one on, and the others are directly north-south, north-south. That's the obvious answer. So, yeah, that is, I have to play with that. So many things to do, so much to do, so few me's to do it. But it is surprising. I keep saying that, I'm just so surprised the conversation has been as pointless and useless as it's been. I mean, this is important stuff. Truth is important. People should really give a shit if their evidence is weak. I mean, when I say something like, look, if you're, you have to go to this work. You can't even get it online now, I don't think. I don't know if somebody has it where it's actually available. You don't have to pay to see it. But Eddington's journal used to be readable. Now, I don't know if I downloaded a copy. I really have to look through my old hard drives. But anyway, and you could read it. And you could read these quotes right out of his own journal, okay, where he describes the fact that he was hoping to get 10,000 stars on his slides. And he only got 1,000. Now that's a huge, giant degrade, right? I mean, you lost 90% of your data. That's a substantial whoops, ooh, shit, And this was a really difficult experiment, right? I mean, it wasn't at all the kind of experiment where you just say, this is really easy, this will be no problem. Now, this is really delicate stuff. And, and then even the little quote where he says, I wouldn't stake my life on these results, right in his own journal. And then 6 months later, he's letting the world pronounce Einstein right, that he's proven Einstein right. And you're just saying, well, isn't that politics or something? That should stink. Anybody who loves science should say, well, that's not a very credible thing to be doing as a scientific experiment. That's pretty bad. If your results are that terrible, 90% of your data ruined, yeah, start over. You can't publish that. You can't publish that as a credible experiment. I mean, and they won't even admit that. And the fact that it's never been repeated from space, and you're just saying, well, what's your counter? I mean, I wish I could get Professor Dave. Could somebody ask Professor Dave to answer the question, why haven't they done the Eddington experiment from space? They don't need an eclipse. They only need an average camera. And, but it's 400 times better resolution. Takes 5 minutes. I mean, why haven't they done it? In the 50 years we've been in space, why haven't they tried it? Because we're supposed to believe they've never even tried it. Does that seem right to you? Nobody even thought to point a camera, 10 degrees away from the sun and find a couple of stars and see if you can see if their light is all bent all over the place? I'm just surprised that people are unwilling to concede that that's not very good looking physics. That doesn't look like good science. That looks like bad science. Let's see. Hard to get a hold of these channels like Professor Dave. Yes, I mean, it's very difficult to get any real communication out of these people. They are terribly cowardly. Well, I guess I'll have to try to do that. I don't know. I can, I'm blocked on a lot of channels, but I guess I could see if I can just ask the. It's hard to find a relevant video. I don't like being irrelevant in somebody's channel comments. It's just too bad you can't do. It's too bad they took away commenting. Where you could just comment on their channel generally, and they took away that feature, which I think was not a good thing. I mean, it's like you could send an email without it being an email. But anyway, it doesn't matter. I mean, it's already, the system is what the system is. And such. All right. I'll give it a couple minutes more and then get out of here, I guess. Yeah, I'm still struggling with the nicotine thing. It's funny. It's just, I mean, struggling is a tricky word to say. It's like it's worse when, say if I drink this now, right? I'm going to have a little bit of coffee. Now, right now, I really want a cigarette. Yeah. So it's like after you consume anything, eat or drink, it's like, God, I really want a cigarette. Really need some nicotine. So I guess I should just make myself some sort of little some little tube to sniff on or whatever, and see if that's just all I need to do. Maybe it's just pretend. Yeah, it's been 2 weeks. 2 weeks without nicotine. 2 weeks. Yeah, I just don't like the way I feel, but I'm hoping it's going to get better and better. Yeah, like I said, it's really most of the day I'm okay. I'm not obsessed. But it's just like there's like every 25 minutes or something, I'll get this little twinge of I want a cigarette. And if I just bear with it for a couple of minutes, it goes away. Or I'm able to think about something else and get lost in it, and I forget that I need a cigarette. But I was just hoping it would be a little better than this, because I just hope I don't have to spend the rest of my life being nagged by the fact that I don't have cigarettes. I remember my father said something once. He quit. When I was born, and he said something to me. Much later about when I asked him about how he quit. And he just took cold turkey. But he kind of implied, or he said something like, I said something. Well, you never want a cigarette again? He says no. Sort of implying that he still did want to smoke a cigarette, but just knows he can't. And I just like, oh shit, I hope that's not how it's going to be. But whatever, I shouldn't. It's not as bad as I thought it would be, so. But it's not as good as I was hoping. Let me just put it that way, I guess. Yeah. It's not as bad as I feared and not as good as I hoped. Yeah, you've been talking about it. Yeah. Ooh, I just synthetically nicotined myself. Yeah, it is a. It's very. I can't imagine doing anything without a cigarette. So I'm just, like I said, this is all new territory for me. It's just. I've been smoking. I started when I was 11 years old. I mean, I've been smoking a long fucking time. And 2 packs a day kind of smoker. So I think that's part of it, is that I was using pretty heavy doses of nicotine. Even when I was vaping pretty thick. And so that might be part of why it's going to take a little longer. Yeah, it is. Obviously, it's one of those things like circumcision or something else. You really can't know it without knowing it, right? You can't say anything. You can't play both sides. You're stuck with the side you're playing. And so, I don't know. I don't want to say anything good about nicotine, but I'm just saying that. I mean, I hate to blame the fact that I appear to be smarter than most people, and blame it on nicotine and say, well, yeah, if it wasn't for nicotine, I would have never had the clarity, the mental focus. And it's true that a lot of scientists were smokers, and really heavy smokers. And so, there is a little bit of evidence that these things go together. But yeah, I don't want to say, like I said, it's stupid to say anything good about nicotine. But I can't deny the fact that I lived that life. In some respects, I liked it. I liked the control that I had, where I could control how much I smoked, or if it was just controlling stress and controlling how you felt, and it gave you some control. And I guess that I appreciated having that little bit of control, because I need control. Control is really important to me psychologically, because I always felt I always felt being controlled by the world, and I always, this idea of being in control is kind of something you want to hold on to. And so I guess that was my biggest fear in quitting, was handing myself over to giving away my controlling mechanism. And I hated doing that. Yeah, the what ifs are really interesting in life. You could just little tiny things. You just say, well, I could extract one event from my life and my whole life would have been different, this kind of stuff. And it's just so funny how, what I would have been, what the other people I could have been would have been for just tiny little events. You just change one little event, one day, take it away or add one day, one little thing, and I'm a different person living a different life. So it's very, very weird, scary kind of thinking. How, and then you're saying for your future, what am I dancing on right now? I'm dancing on some kind of ice, and one misstep, and I lose 10 years of my future, some kind of thing like that. It's all really, really creepy, to be this vulnerable to the whims of the world. This makes me think more about the whole fact that people are so glib. And it's just, they're so, like all of this is, that they really aren't on the razor's edge. At any minute they could just be split in half, cut in half. That everything disappears in one moment. One misthrown cigarette butt. Yeah, we had a fire next door here, and it was hilarious. So it was one of those e-scooter kind of things, and the battery, I guess, got recharged poorly or something. Well, anyway, so it was a garage fire, but it wasn't even a fire, it was just smoke. but there had to be 50 firemen out on the street. I mean, it was just, it was an incredible show. Well, I can't really go into it all, but I mean, it really is Keystone Cops. And these are professional. These are paid professional firemen, not volunteers. And it's just you're just saying, what would the Three Stooges do? And whatever you think the Three Stooges would do, that's what the firemen are doing. It's that fucked up. So, yeah, maybe someday I'll go through all that, different. I mean, there's so many little things that happen that I'd like to talk about, but can't do that because the trolls will ruin it all and fuck around with any information you provide, and so there's no point. But it really was a spectacularly funny show. Well, I don't know about who's clueless. I mean, frankly, the young people like yourself, I wouldn't put them in any kind of category of brilliantly enlightened. So I don't know what you're talking about exactly. I mean, I can't think of anybody under 30 who makes any sense that I've seen. So, it's pretty rare. They're all worried about makeup and what color hair they should have today and what kind of Furby they should be next week and, all the whatever, all kinds of silly distractions. Video games, not even being able to get free of that nonsense. I mean, recognizing what a trap it is. But I shouldn't talk. Like I said, it's probably you probably can make a comparison between nicotine addiction and video game playing. I don't know. Well, maybe, I don't know. It's certainly not the same thing, but I could feel it. I could definitely feel that when I was playing video games, that this was not gonna, that it was almost like I could watch it and say, I can feel this is going to be just like cigarettes. It's going to control me, and and so I had to just walk away because it was just too easy to get lost in the simplicity of it and ignore reality. But yeah, you could just argue that the whole human race has just gotten stupid. I don't know how everybody got so stupid. People did not seem this stupid when I was a kid, but I mean, maybe that's just because I was a kid. And I didn't realize how stupid they were. But fuck, it does seem like now everybody's just walking dumb. But some of it I don't understand, I guess, It's like people buying pit bulls. Buying them. I could see if they were giving them away or something. Okay, you just want any cheap, shitty dog you can get, but paying money for a fucking menace, a liability, a huge problem dog? Why the fuck would people do that? It's just because nobody would get a pit bull when I was a kid. I mean, it was an ugly, dumbass dog. Nobody wanted a pit bull. I mean, there were people who had pit bulls were people living in like Arkansas or drug dealers. I mean, no person had a ugly, stupid, moronic, smelly, ugly, but ugly dog. I mean, nobody did that. I mean, they got a collie or they got a, golden retriever or a Labrador. Nobody got a pit bull. Nobody. You're just like, where did this come from? And after me being attacked by one, it's just so obvious that, yeah, okay, it's not a lie. These dogs will kill you. I mean, I was so fucking lucky. No, not to, to leave the encounter with my face still intact. And I mean, it's just so people just say fuck what everybody says, fuck what the evidence shows, fuck all that. Let's get a dog that might eat your kid. I mean, it's just so fucking stupid. Yeah, I don't play any video games anymore. That's right, but it's just a little bit. It's pretty easy to get caught up in it. Boy, it just. Ooh, this is a fun game. Ooh, this is yeah. No, I don't want to do that. They're all. I just know there's so many stupid things. I mean, there's more on. After all that's been done and said about life and welfares and all this stuff, and there's some 22-year-old fuck some bitch, has a kid, he has no job. They're both of the parents are living in their parents' house. I mean, how do people do that kind of stupid? I mean, how do they get into a mess like that? I mean, how can they not understand? There's just no excuse for being that fucking stupid. I mean, these aren't people that were raised in a slum. I mean, these are people middle class, they had, both the parents work, real family. And this is what they produced, is children this fucking dumb. And you're just saying, I don't even know how they could be that fucking, how could it be possible they could be that dumb? Even car accidents, I mean, they don't even take that seriously. Because I guess airbags has made everybody feel like they're immune, that they can't be killed or harmed anymore. Or something like that. Because that doesn't even teach people anything. They have car accidents and it doesn't teach them a motherfucking thing. Yeah, you're just like, how do you be that stupid? I just don't even, I can't even imagine that kind of stupidity. Like, why would I want that life? Oh. Why would I want responsibility for 3 defective kids? Or 1 defective kid, or any kids? Why would I want that responsibility? Well, I don't think it's gonna. I'm sad about this physics thing because it looks like everything I'm talking about, nothing's gonna happen until long after I'm dead. So that's gonna be the disappointing part. That I think maybe AI will eventually be better organized to be a better thinking device. That is, they'll realize it needs to have a growing intelligence, not a stagnant, regurgitating intelligence. And maybe eventually it'll figure out like this easy thing. Like, how do you make charge? Well, you just have 2 kinds of force and 2 kinds of matter and just inverse the relationship and boom, go, you got it. So it'll be, I guess what I'm saying is my arguments will be made by somebody else eventually. And maybe somebody will trace it back and say, oh, but this guy did figure it out first. Maybe they'll do that, but who knows. But yeah, you can't reason. I just don't know. Like I said, and it's only going to come. There has to be some physicist who grows a set of balls and challenges the establishment. But they can only do that. I mean, frankly, they're not going to discover what I discovered, right? I mean, it's not likely that they're going to do it within the same time frame that I did it. It'd be kind of silly to say, oh, the magical year for physics was between 2000 and 2015 and 2025. That somehow that was the magic period where 2 individuals figured out all of this crap. So that's not likely. So unless somebody figures it out on their own, and he's already famous, and then he can argue it with the physics community, how else is this going to happen? The only other way it can happen is some physicist like Veritasium has to listen to my arguments and be convinced and then say out of the goodness of his heart, I'm going to do the right thing and show the world this good idea. What's the odds of that? Yeah. No chance. So it is interesting. I mean, it should be, like I said, if I can just get some of these cowards to do, like I said, we do have the Valerie guy on the hook. He has the air track. If he does the 4 rubber band experiment, it should be easily demonstrated that he's going to get a hell of a lot more than twice the velocity. Okay, a hell of a lot more than twice. Okay, it's going to get more than 3 times the velocity, and it's going to be more than enough to prove that it doesn't take 25 times the fuel to go 5 times as fast. And you know, and then so, but we have to get somebody in that kind of position, a physics teacher. I mean, I was trying to get the Paul Nord guy to pay attention. He wouldn't do it. And Bruce Yearney guy seems like he's right on the cusp, almost ready to make a video saying, yeah, there is this argument out there that kinetic energy is a lie and it's just not true. And maybe we should develop some experiments to tease the truth out. I mean, he's almost there. I mean, just gotta, I gotta do something. This isn't working, so I do have to do something. I have to figure out some other way to make myself relevant. And have experiments done. Competent experiments. Alright, 2-minute warning, I guess. So, I'll add a coffee. I appreciate the participation. Sorry, it's only the 3 of us usually. Guess there was 1 added person here. Oh yeah, it's always a little thin, but better than nothing, obviously. You think in the future physics will come around because intelligence will demand the right answers. Well, obviously, I think you can't stop the progress of intelligence. That is, it's a staircase and you have to go up the staircase. Obviously you can stumble, and so I'd argue this is the stumbling period. So it's like the Dark Ages or something. Something happens where you start burning the books and doing all kinds of dummy stuff, and then you recover and go back to walking up the staircase. So when people raise children and educate them, not to play video games, but to be useful and thoughtful and productive and inventive, well, then those kids will want the true narrative. They're not going to want to live a lie. I don't think. So, there'll still be some reason to think there's a truth beyond the propaganda. Especially the propaganda of the birthers and all that kind of crap. Oh, so Dark Endless guy, yeah, I did want to talk to you that maybe we should do maybe we could do a physics conversation, and that would be good practice for you and me in terms of, but obviously it's a little bit one-sided in the sense that, I'm not following you, you're sort of following me, but, it might be just a good thing to do, and then we can try maybe doing the emendum kind of conversation stuff, but see how far to go, because I did notice you wanted to thought the conversation might be worth doing. See, I always think that the only conversations that are useful are disagreements. People who agree with each other don't necessarily open any new avenues, but that's not true, because like I said, the guy I worked on the simulation with, our conversations about making the simulation were really quite useful in terms of seeing things from new angles. So that doesn't hurt. But we'll see. See if it was. See what you want to do. So email me, something like that. And regarding what you would like to do in terms of a collaboration of some kind. Oh. And such. Yeah, well, they're all good videos. Yeah, very good. Yeah, they're all good. All right. So, well, yeah, like I said, just email me, and we'll figure out what to do. Yeah, this you can do a live room in YouTube still. I don't know what it's called, but it's called something meat or something, or some kind of. It's got some sort of name. So I can do that, or if you have one of those accounts with StreamYard or whatever it's called, some other software. Kind of disappointed that Microsoft killed Skype. Just doesn't seem like the kind of thing you would kill. I could see you modifying, but why kill it? It just seems like a silly thing to do. Well, yeah, I mean, once you get into it, you're going to have to be stuck with paying the price of being on the hit list. But I think he already knows that. I think he's already been hit. But, yeah. Unfortunately, I am... Yeah, I guess I am. I carry some liability. There is a downside to being associated with me. Even though I don't believe I've ever done anything to deserve that. Alright, so I guess I will be on my way. So, till the next time, and such, and so forth, and whatnot, and all that. Blah, 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 blah. Blah, blah. Let's see, where's the right window? There's the one. Okay, end stream. So, see you next time, and such, and so forth, and whatnot.